Good afternoon, everybody, and welcome to MOS Live for our very special event and presentation where we are going to learn a little bit more about the Mars rover Perseverance and experience the landing of it on the red planet Mars all together. Super exciting. My name is Karen. I am one of the many educators at the Museum of Science. Super excited to see so many participants this afternoon with us. We're also very excited here about this particular event. I'm going to be acting as your moderator, so I'll kind of be in the background, but I'll be keeping an eye out for any of your questions or observations or comments you have for our lead educators today. In order to interact here on Zoom, you can find the Q&A button. Click that and just type in your question or comment, and I will relay as many of those questions and comments as I can through the group, including our panelists. Now on Facebook and YouTube Live, we so appreciate that you're tuning in, but unfortunately we cannot field comments and questions from there. And lastly, before I pass it on, if you do need closed captioning today, that is available by clicking the CC button and choosing Show Subtitles. With that, I'm going to invite my fellow educators to join me and introduce themselves.
Hi, everybody. My name is Eric. My pronouns are he, him. I'm an educator at the Museum of Science, crazy about all things space, and super excited for our landing attempt today.
Hi, everyone. My name is Sarah. My pronouns are she, her, and as just a longtime Mars nerd, I am chomping at the bit right now. I am so excited for this. So we wanted to start by giving you just a little bit of an overview of what this is, what we're going to be talking about, what we'll be seeing, and how long you can expect this to last. So the landing of the Perseverance rover on Mars has already begun. It actually started, we started getting signals for its landing sequence about 7 minutes ago. Now, you might have heard the term 7 minutes of terror. We'll get to that in a little bit. That's going to be coming in about 15 minutes. So get your terror ready, but we're not quite there yet. Right now, it's just beginning to sort of come closer into the atmosphere. Now, this rover is very similar in design to the Curiosity rover. It left Earth in May. We did a little live stream then for its launch, and now it's already landing time. How time flies when it's this crazy year. All this got done still. So here's what we are going to be seeing. We'll be seeing some footage from NASA live streams. We'll be seeing some control room at the Jet Propulsion Laboratory, and we'll also likely be seeing some really, really cool images and animations to go along with what's happening. What we will not be seeing is video footage of a big thing coming down to Mars and landing on the surface, and that's because there's no film crew on Mars. You would have heard about it if there is a film crew on Mars. There are no cameras in situ on Mars for us to see. So that's kind of part of the terror here. We're gonna have to trust that the Perseverance rover goes through this whole sequence pretty much automatically and all in time. So we're going to be talking a little bit about the rover. We'll be answering some of your questions, hopefully, about Mars in general, about this mission, about the rover, anything else that goes along with it. And then we'll be sort of jumping into the live stream to make sure we're there for all the most exciting moments. Anything to add, Eric?
Yeah, just that, like you said, if you have seen any pictures or videos or anything of the rover coming down, those are all animations of what it looks like when everything goes right. What we will see when we tune in is a bunch of really tense controllers sitting around their consoles waiting for signals to come back from the rover. And we will get pictures from it later. We will get first-person video of the landing as it comes in later. We have to download all that from Mars. That takes a few hours, a few days. What we will get today is basically the blip signal that the rover gets down on Mars and says, made it. And that signal takes 11.5 minutes to travel to Earth. When it gets to the control room, what we hope to see is the controllers get that signal and then start jumping up and down and hugging each other and going crazy like they won the World Series. So that's what we're hoping to see. That's scheduled for about 3:55. So we've got 20 minutes to talk all about the rover, how it's going to land, what it's going to do when it gets there, and other things that we expect to see. Do we have any questions that are come in so far, Karen?
Yeah.
We have so many questions that have already come in. So let me know how many you want to take now before you give a little more background. This is one of my favorites, though. It was the first question that came in. Who named Perseverance? Because I know it has a really good story behind it.
It sure does. So the generally naming a rover happens kind of later in the mission. The Curiosity rover, up until it launched, was known as the Mars Science Laboratory, or MSL. This one was called Mars 2020 for a very long time. But indeed, the naming contest took place in the year 2019. It was for American school children aged kindergarten to 12th grade. They could write an essay describing why they thought what the rover should be named and why. And then they asked some judges, including me and Eric. We were both on the judging panel to read a bunch of these essays and decide what the winner was. And the winner, I don't remember the student's name, but the student was a 7th grade boy, and he came up with this name, Perseverance, to represent a great quality in humanity, as our ability to persevere. And like I said, that was 2019. So we didn't even know we were going to be persevering this whole mission through a pandemic. So it was prescient.
Yes. And then there have been several questions about, is this the first rover on Mars? When was the first rover created? So maybe just a little background about this particular rover and rovers on Mars in general.
So we've sent lots of spacecraft to Mars, but not very many rovers. Rover is kind of like the biggest, most complex and hardest mission. So we started by doing Flybys of Mars, which is just the spacecraft zooms by and it takes a couple pictures. That was back almost 50 years ago at this point. We can do orbiters, which stay in orbit around the planet. We've got 6 of those right now around Mars, looking at its atmosphere, its weather, basically serving as like radar control stations to relay signals from Curiosity and this new rover, Perseverance, back to Earth. We've got landers, which go on the surface and then they don't move around. Sometimes they don't need to. Sometimes it's just easier to get a lander that doesn't have to move. And rovers are the ones, the really big rock star ones, the wheels. They've gone really far. We've had rovers travel over 26 miles, longer than the Boston Marathon on Mars. Sarah's going to help me out with the exact list because we have Curiosity that's been there since 2012, still going after 8 years. Spirit and Opportunity, the twin rovers that went, one of them, Opportunity, went a lot longer for 14 years. Was it, Sarah?
Just recently, 2018 was our final sort of officially Opportunity was declared mission end. We can talk a little bit about why that happened if there's any questions about the power source, because that's what it had to do with. And then the Pioneer was Pioneer and Sojourner, right? Those are the only others.
Yeah.
So NASA is actually the only agency that's ever landed a rover on Mars. But right now, there are multiple other missions, including Europe's Rosalind Franklin rover, that are trying to get to Mars, and the more the merrier when it comes to robots on Mars. But yeah, right now the only active rover on Mars is Curiosity. The other active robot on Mars is InSight, which is just a lander.
Awesome. That was some great history. We also have a lot of questions sort of about what its mission is, like what is it looking for?
Yeah.
Do we think it will find life? How likely is life on Mars was another question I saw.
Great question, and that is the sort of center of it. The primary mission of Perseverance is to study habitability of Mars. Now, to inhabit a place is to live there. Up until now, we have no evidence of there ever having been life on Mars or there currently being life on Mars. But we have learned a lot, especially from the Curiosity rover in the past, almost 9 years now. I guess 8.5 years Curiosity's been on Mars. We've learned a ton about how much water there used to be on Mars. We've learned about what Mars's atmosphere used to look like. It used to be a lot thicker. Mars used to look a lot more like Earth and used to be covered in almost just like Earth. A lot of its surface used to be covered in oceans. And we've learned almost all of that because of Curiosity. But Curiosity was just kind of going to explore, whereas Perseverance is going with a lot of specific instruments to look at things, to look for evidence of especially fossilized microbial life. That's what we're really trying to look for. So the landing site was chosen for that. It's got a lot of other instruments that it's bringing with it to look for life on Mars. As for how likely life on Mars is, I don't know, Eric, you want to take that one?
Oh, I don't know. I'm too excited by the possibility to think logically and come up with because it's so exciting. I was kind of just thinking today that this mission is going to land today and carry out its primary objectives in the next few weeks and months and explore this really interesting site that we've never been able to get to before. And we might be able to say in the next couple months, you know what? We found fossilized microbial life on another planet. that might happen this year. Of all the years, centuries that we've been thinking about it, 2021 might be, no, Earth isn't the only planet with life. It's crazy to think about that.
Yeah. And we have found a lot of really fascinating things on Mars. We found a lot of signs in Mars's sort of geological record and its rocks that suggest that it really did used to look a lot like Earth in terms of its chemical composition, in terms of how water moved. All those things were really important when it came to life developing on Mars. But what's cool is that the other sort of part of habitability is to kind of help pave the way for getting humans to Mars. A manned mission to Mars would be a lot more dangerous, a lot more difficult than a robotic mission, a lot more expensive. And so Perseverance is going with a lot of experiments to help us learn about how hard it would be to live on Mars. One of those experiments is called MOXIE, and MOXIE is going to be trying to create a little bit of oxygen on Mars by using the existing chemicals in Mars's atmosphere to make breathable oxygen, just in very small amounts. It's basically a proof of concept, but that's a really exciting project. And so yeah, when we say habitability, we mean all across the spectrum.
There's also a lot of questions about sort of when it launched, how long it took to get to Mars, will it come back from Mars? The ever-pressing question about our wonderful Percy.
Why would it want to come back?
It launched on July 30th from Florida on an Atlas V rocket. It spent a little bit more than 6 months now getting out to Mars because Mars is really far away. And it just takes that long to jump from one planet to another in the solar system, especially when both are moving targets. It's going to land on Mars. Its primary mission is for about a Martian year. So it's about 680 days. And it'll probably get many mission extensions. Curiosity, the previous rover, has gotten many mission extensions. It's been going for 9 years now, almost. And yeah, it's going to stay there. It has no plans to return, although what it is going to do is gather all these interesting rock samples on its way. It's going to do science and analyze them with lasers and drills and cameras and ground penetrating radar, but it's also going to cache those samples, which means grab onto all of them, put them in special tubes, and then at a couple places on its journey, it's going to just drop them. And then we know where those locations are, and we're going to go get them in another couple years. We're going to bring them back to Earth and study them in our labs here because we have way better instruments on Earth than we can send all the way to Mars. We have instruments that would never fit inside a rocket. Things, X-ray machines and CAT scans the size of an entire room that we can use to learn a lot more about those rocks. Think about the rocks that came back from the moon. We brought them back so we could study them here on the Earth, and we're still finding out new things as technology gets better. So even though the rover itself isn't going to come back, it's going to drop off all these interesting rock samples all along its journey so we can grab them and bring them back.
Cool. Now, you guys talked a little bit about the atmosphere around Mars, and I know, of course, the rover is going to have to move through that. What exactly is the atmosphere made up of?
What a great question. So I got my degree studying the atmosphere of Mars, and Mars does have an atmosphere, but not a very thick one. It's about 1 to 10%, depending on where in Mars's atmosphere you measure, as thick as Earth's. So it is a very, very, very thin atmosphere. That's a lot of carbon dioxide, is sort of some of the major compositions on Mars. We have also found some other really interesting gases on Mars, including methane, which is one that here on Earth is often made by microbes. So we're always excited when we see methane on Mars. There's a methane cycle on Mars that we don't fully understand, and that Perseverance can hopefully help us to figure out. The other awesome thing so Mars's atmosphere being thin makes communication a little bit easier, but it makes landing harder. We'll have to talk about that in a little bit. But what's great is that because Mars has lower gravity than Earth, as it is a smaller planet, it is still easier than a lot of other things would be to send some heavy stuff there. And that does include Percy's little stowaway, which is a small helicopter called Ingenuity that is going to be, it's like a little drone quadcopter that's going to pop off and fly around over above Percy, take a bunch of pictures and study the lower atmosphere of Mars. So we know a lot about the high atmosphere of Mars. We know a fair amount about the surface of Mars. We'd love to know more about the layers of that atmosphere. So Mars is really cold, really dry, and an okay place to fly around. I hope that it's easier than it is here on Earth.
Now, how are we doing on time? We still have over 100 questions that have been left unanswered, but I know that we also want to make sure that we don't miss NASA feed. Are we at that point yet, or do you have time for a couple more questions?
So we are about 20 seconds away from atmospheric entry. So I think it is time for us to make sure that we are looking and listening to our awesome NASA cohort. And
I think we should have time for questions after the main event also. We'll hang on for a little bit.
Sure.
So chances are we'll probably stay on this until 4:15 maybe, my guess.
Right. So again, everything we're seeing is live from NASA's headquarters and 11 minutes delayed from Mars. So actually right now, Perseverance is, with any luck, already sitting on Mars, starting to unfurl its instruments, starting to send back most of the signals, the data from the landing. And hopefully that signal of, yes, I made it, is about a quarter of the way back to the Earth. So we'll watch live the controllers in the control room, hopefully, like I said, probably sitting around really tense, watching all their data and instruments.
Biting their nails just like we are.
The landing as it happens. So how do you land a robot on Mars? Because at the start of that journey, it's going about 15,000 miles an hour. And then in the span of 7 minutes, it has to go down to 0, sitting on the surface and not moving. So what happens is you slam into the atmosphere of Mars. The air actually helps you slow down. It's really hard to land on Mars because that thin air, you can't ignore it, and you can't just land like we do on the moon, but we also can't really use it too much. It's not very efficient, so you have to use it cleverly. So we use a heat shield, slam into the air, and the air physically stops the spacecraft from moving so fast. It goes down from about 12,000 miles an hour down to about 1,000 miles an hour. And then when it's above the surface, about 36,000 feet, right at cruising altitude for most airliners, it pops open some supersonic parachutes and slows down even more. It's going to get down to about 200 miles an hour because, again, the air is really thin. After using those parachutes, it's still going faster than a race car. So from there, it's going to head down towards the landing and activate the sky crane. This is really why we call it the 7 minutes of terror. It has to activate retro rockets that fire down. Instead of boosting the spacecraft up, it's going to slow it down as it comes down, fire those rockets. It's going to make it all the way down. A big tether will come down and gently deposit the rover, hopefully on the surface. That sky crane will blast its rockets, fly away and crash somewhere safely away, and we'll have a robot on Mars. So all of that already happened. Again, we're just waiting for the signals to come in as it's happening. And you can see that control room there.
Just tense. So we've already gotten to the stage where we're at the maximum amount that it needed to slow down in a short period of time. So basically they had to fire some reverse thrusters. They've already gotten past there. The next step that we're looking to hear about, you can see some of those stressed out JPL employees, NASA employees that Eric was mentioning. These are some of the incredible engineers and scientists behind this. So what we're looking for is evidence that heat shield, which is that there's sort of a bowl shape on the bottom, that's starting to skip across Mars's very thin, but still quite present upper atmosphere. So until this point, there hasn't been any drag. There's been nothing sort of causing problems or anything like that. But there are now, this is when we enter into the stage where something could go wrong, but it's probably not going to. It's probably going great. There's lots of engineers who worked really hard on it. And this is very similar to the design of Curiosities, but we can listen in and see if we want to hear what they're talking about here on NASA. So
We've had a lot of questions, Sarah, about what's the likelihood of a successful landing? What if it doesn't land correctly? Is there a backup rover?
About 15 kilometers from the surface.
Okay.
Nope. We sent this rover, and it's the only one that we have on the way right now. The only one NASA has built for this window of getting things to Mars. And so if it doesn't work, then it doesn't work. And that has happened many times. Mars is littered, the surface of Mars, with the broken pieces of spacecraft that made their attempts to land. Many of them, for lots of different reasons. But hopefully everything goes well and we get that signal back that that we landed.
I see people clapping, so I'm hoping that means, yes, it does, that the heat shield has separated and now the parachute is open. Now, this is no normal parachute. This parachute is like 50 feet wide and made of hyper thin, hyper light fabric.
The heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second and an altitude of about 9.5 kilometers above the surface.
Okay, so we're just under 6 miles. So we're around just under 6 miles from the surface. That's good. We're gonna, I'll mention something we always want to mention in these live streams. If you ever hear something said if they ever say nominal, that's good. That's a very good word. That's the best word. We want things to be nominal. Up until this state, they're always going to be kind of chill about it. You'll hear them. There's somebody whose job it is to say, okay, that thing that I built is working. You'll see
polite clapping. That means good.
Yeah,
the next step
claps.
happened. We're not celebrating yet. We're glad that the next step happened right. You can see the data down at the bottom is coming in fits and starts. We don't get a broadband connection to Mars. We just kind of get blip signals. So we're getting lower. And at this point, the rover, this one, it's going to land with its eyes open. The reason we could go to this unique and really challenging landing site in this crater is because the rover has a camera and a computer on board. It's going to continue to take pictures, analyze all the areas. It has a map built in of Mars that in its head, in the computer's mind, it knows which pixels on that map are safe to land in and which ones aren't, and it can aim on its way down.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars.
Okay, folks.
With confirmation that the back shell has separated. We are
Okay.
performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Divert maneuver. So now it's aiming. So now it's picking a landing site. It's picking a place that's nice and flat. No cliffs, no boulders.
Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Again, this is a simulation. Anything you see of the actual rover is what it would be happening. It's not live footage. It's a computer simulation of what actually happens on Mars.
Accordion, which means we are conducting the sky crane.
Okay, so now
About to conduct the sky crane maneuver.
this is happening.
We've lost direct Earth tones.
As expected. As expected.
Sky crane maneuver has started.
All right, and any second now. Maybe the next thing we hear.
We're getting signals from MRO.
UHF is good. Touchdown confirmed.
Yes!
Ready to begin seeking the sands of past life.
All right, touchdown confirmed. So we have the signal. We have the, yes, I made it. Yes, I landed on Mars. I'm safe after that 7 minutes of terror. We can start our mission.
Exciting. When might we first get images from Perseverance? Later today or not until sometime tomorrow? I know it still has to like unfold out of its capsule and like roll its little self out. It's what, SUV sized ish.
Yeah, it's about the size of an SUV, and has a whole list. Oh, it always makes me so emotional seeing them so happy. So it did land actually pretty much out. Its shell rocketed off and went somewhere else, as did the sky crane.
Cool.
That's just somewhere else. It's gonna open up those. It's gonna open up those heat shields, or it's going to open up its wheels rather, which are an improved design from Curiosity's. Curiosity's wheels are the first thing to sort of begin failing. So it's going to extend those wheels, and then, yeah, it'll extend its robotic arm. It has a robotic arm it can use to manipulate stuff that it can also use to take selfies with. So hopefully that is the first thing we'll be getting, is a selfie of Perseverance on Mars. We can expect that, I would say, within the next 24 hours. We're likely to see that.
Yeah.
I remember the first picture that Curiosity sent back, and it was like super exciting. So I'm just excited to see those first pictures of our buddy Percy.
Yeah, Percy's there. Okay, so questions. So now we're good. Now a weight has been lifted off. It landed, it made it, and now we can really start digging into what it's going to be doing. So Karen, I can
So
see
someone actually just asked, how long do we expect Perseverance to work or to last and work on Mars?
So it's basically almost a copy of the Curiosity rover. It actually used spare hardware and the same design because a little bit of it ain't broke, don't fix it. We know that Curiosity worked great. It's using the same design, updated technology for the instruments, cameras, a lot of different science things. And also, like we said, upgraded wheels. The wheels on Curiosity, you can look up pictures. They're getting kind of run through the mill. So I actually, on the podcast that we have, Pulsar, I talked to the lead mobility engineer, Rich Reber at JPL, and he told me all about testing the wheels for this new rover, and he called them bomb-proof. And he told me a great story of how they took the rover wheels out to the Mars yard for this new rover, and they ran them for 20 kilometers around the track, and they put sharp rocks in front of it, and the rocks were wearing down and getting smooth because the wheels, and they took Curiosity's wheels and put them on, and they lasted for about 100 yards and broke apart. So he said that the limiting factor for the mission would be the plutonium fuel source runs out after 15 or 20 years. That will happen before the wheels fail. So that's kind of the limiting factor for the mission. If the power source runs out, if we just decide to retire the rover because it's found out all it can about the area that it's in, we've already seen that this almost exact rover can last for a decade almost. And so hopefully we'll get a lot of mileage out of this rover.
Yeah, robots tend to be built to last.
Its power sources. I know that was one of the problems with Spirit and Opportunity back in the day, is that they were solar and we thought they were only going to last 6 months because it would get covered with Mars dust and then they couldn't recharge. But hey, guess what? Mars has wind. So is Perseverance also solar powered or nuclear?
Yeah, no. So Curiosity and Percy, neither of them have solar panels. They're or if they do, they're for like some minor instrument. They both have plutonium-238 engines. So those are nuclear powered. That has been shown to be a lot longer lasting on Mars because of Mars's dust. So Mars has global dust storms that happen every year or two, and those can be pretty problematic for a robot that needs the sun. So the Perseverance rover will be able to stay warmer. It'll be able to continue functioning during the nighttime, during storms, during all kinds of different things with that plutonium power source.
What is the temperature swing that the rover can handle? I know I saw that question at some point. I think it was specifying how hot can it get, but also I guess it gets cold on Mars. How cold can it get?
So they have, because of the plutonium-238, any instrument that needs to be kept warm or that needs to be warm while functioning is built to be closer to the power source. So that's basically how they build it. They build from the inside out what needs to be close to it and what doesn't. So it should be able to handle Mars nighttime winter temperatures, which is like 100 degrees below zero. So it is robust. It is a robust robot.
And in thinking about its trip out to Mars, Jules, who's 9, wants to know, how much fuel did the rocket take on its way out there?
A lot. I mean, you're launching the end result, the rover, the size of a small car, and the rocket that we used to launch it all the way out to Mars, the size of a 15-story building, and almost all of that is a giant fuel tank. You've got giant fuel tank, tiny little robot at the top, rocket engines at the bottom to burn that fuel. And so we need millions of gallons of rocket fuel to leave the Earth's gravity behind and get all the way out to Mars. And then once it was on its way to Mars, it kind of just coasted all the way there and then hit the atmosphere, used all that to slow down. Those tiny little rockets right at the end used just a tiny little bit of fuel. So almost all of that fuel was leaving the Earth's gravity and getting all the way to Mars, getting fast enough that you could travel from Earth to Mars. An unbelievably large amount of rocket fuel compared to
15 stories of rocket fuel.
It has to bring it all with it. There are no gas stations along the way.
Not yet. Maybe someday.
Sort of a related question, the fact that everything had to go with it. How much time and, of course, money sort of went into building the rover, launching the rover, getting it to Mars with all the stuff that it needed for its existence?
About one bomber's worth. $2 billion. The Perseverance rover, this mission was approved in 2014, I believe, 2014 or 2015, for a max of $2.5 billion, and they came in under budget on this one. So that, of course, that's a big number, and is not something that a single person can really bankroll, but luckily it doesn't. NASA is working with lots and lots of scientists all around the world, working with different space agencies. We're coordinating with Europe's space agency for communication. So they have an orbiter around Mars that's really, really useful for pinging signals to and back. And so basically the whole thing, any long-time space mission like this one has to be designed to be able to keep functioning on as little budget as possible. And that's what they're able to do by building these really awesome instruments that are built by sort of separate groups, and by having this maintenance that they've designed to be, the robot to be as low maintenance as possible once it gets there. So good thing it landed.
So we talked about how cold Mars can get, but somebody asked on the other end of the scale, how hot is Mars during its summertime? What is like an average high?
Surprisingly nice.
Yeah, like 30 degrees.
I lived in North Dakota for a time, and there was weeks long where I would look up the weather report from a Mars weather station on the ground there that we had on a lander or a rover, and it was 15 below Fahrenheit outside of North Dakota, and it was just warmer on Mars. The cold isn't all of the story though, because the atmosphere is way, way thinner and made up almost entirely of carbon dioxide. That doesn't mean that on a nice day on Mars, you could just step out of your spacesuit and enjoy it. So there's a lot more going to it, but the temperature itself of that air at the equator in the summer, when the sun's beating down on it in the middle of the day, can be nice.
Excellent. So this is a great question about the helicopter. Somebody had asked how it got named, but this person is asking, is it already launched from the rover? And how will the helicopter know where there's a rock or a crater when it's flying? Does it sense it itself and move another direction, or is like a human controlling it?
Good question. So the problem with remote control when it comes to something on Mars is that you have about a 5 to 20 minute delay. Currently, it's 11 minutes, depending on where Earth and Mars are in our orbits. We're closer or farther apart. Right now, we're about midway. We're about average 11 minutes. So that means that you can't really imagine playing a video game with 11 minutes of lag. You probably wouldn't be doing very well at your video game. You'd be behind on everything. So that's the problem with anything on Mars. So most of the rover's functions, as well as Ingenuity, I believe, was named by the engineers who built it, but I think that they named it to go along with Perseverance. Thematically, they went in that same direction. I'm not 100% sure about that, so I might have to double check that. But so basically what it'll do is it'll run programs. They'll basically say, okay, we're going to fly straight up, fly around a little bit, take a bunch of pictures, and then come back and find the rover. So the rover and the helicopter can communicate with each other. And so that will help with certain, the rover has a lot more sensors, a lot more instruments for things. The helicopter has not launched yet. I believe it'll be launching in the next 3 to 6 weeks as we kind of begin these various like instrument checks, turn on, drive a little bit. But yeah, we'll make sure to let you guys know on our various social media and things like that when Ingenuity is actually going up to take its first flight. It will be the first powered flight in the atmosphere on Mars, which is really exciting.
Next week, we actually have another live stream. It's Wednesday at 3:30, where we're going to be giving updates and finding out what in this first almost week have we learned, or what has Perseverance done. So definitely keep an eye out on the website and our social media channels. Tune into that one too. This is a question that I really like. Do the NASA scientists ever put extra stuff like souvenirs in the payload for future scientists to find someday? Like, we put little Easter eggs on there that like 100 years from now when humans are like working on Mars. Fine. Love it.
Definitely.
Yes.
There's plaques. NASA usually has for these missions, send your name to Mars. And so they send like a small SD card or something with thousands of names, and your name is on Mars, not printed out, but in that data, on Mars. It's there. And I actually just read this week that they put a tribute to frontline healthcare workers on Perseverance. And there's a little plaque. So you can go and look up pictures of all these things as NASA does. They like to have maybe not so much for future archaeologists to uncover the rover, but when you think about it, the whole rover is that. So, but yeah, usually the missions they sent, the one out to Jupiter was one of my favorite ones. They sent a small Lego minifigure of Galileo, who was the first one to observe Jupiter in a telescope on the spacecraft that then went out to Jupiter to actually orbit around it. So they usually have those tiny little Easter eggs.
I know that Percy and Curiosity also both had, they had some little tones that would be played by certain instruments. So certain instruments had the ability to play back a certain tone, like a boo. And some engineers were able to program Curiosity first to be able to actually play a simple little tune. And so the tune that it plays, that it played to itself is Happy Birthday. So Curiosity sings Happy Birthday every August 6th to celebrate its next year on Mars. And Percy will do the same thing. And I think that's just really beautiful. It's not like a crucial mission sort of procedure or anything. They just sort of were like, hey, you know what we could do with this? We could make it sing. So these are the first two singing rovers.
And this is the first time we'll be able to hear it because on Perseverance, 2 microphones. So we'll be able to hear what Mars sounds like for the first time.
So fun. Can you imagine if you got some really weird sound, even like the smartest humans on Earth couldn't figure out what it is? That's what I'm hoping for, something real interesting. Yeah. Now I know that we've been here a long time. Do we have time for maybe just a couple more questions before we wrap up, do you think? I know we could sit here and do this all afternoon, but
no question.
So there's been a couple questions about, we talked about how big Perseverance is, but do we know how much it weighs?
3 tons.
Yeah, I think
so. It's on the smaller size for a car, space-wise, but it's loaded with science instruments and good stuff. And the wheels are made out of aluminum, and there's all these extra things where a car is mostly empty space for people to go in. The rover is just solid science and engineering. So it's a couple 1,000 pounds.
This one also, because of its greater, there's more cameras on it, there are more instruments, there's microphones, there's Ingenuity. It's about 12% heavier than Curiosity was.
Cool. And then this is another great question, also thinking about the time delay, which I think we mentioned earlier. How does NASA control or drive the rover? You can't do it live.
So I also talked to Rich Reber about this, the JPL engineer that I mentioned on our podcast. We have a whole episode talking about who gets to drive the rover, because it turns out that there's not a seat at NASA that has a picture of Mars on it. You get to sit in it and control the rover with a joystick. It's a whole team of scientists looking at all the pictures of where the rover is, deciding which rock to go to and zap with its laser next. And the point of the technology now is that you can use virtual reality, and those teams of scientists can be around the world, step into the same virtual landscape of Mars and all agree we want to go that way. And then the rover controllers are the ones that go ahead and program in the rover. And it turns out it's not so much go forward, hit the gas, turn the steering wheel. You kind of give the rover an idea of where you want it to go, and the rover drives itself. It's got auto nav. So almost like a self-driving car, it's capable of taking pictures as it goes, using its computer, seeing obstacles, avoiding rocks of a certain size, and driving really, really fast. I mean, its maximum speed is less than 0.1 miles an hour. So you don't really have to worry about jumping out of the way of Perseverance if it comes barreling at you.
It's going to do some sick jumps off of a ramp.
But the turnaround time for the rover being able to go and drive, say, 20 yards to the nearest rock, it's going to be much less than previous rovers because of this way that it can figure out where it is, take pictures, avoid obstacles, and just get where it needs to go.
Yeah, didn't Spirit in its, almost a decade, just over a decade, only travel a couple of feet or something crazy? A really small footprint.
Some of the rovers have had small footprints. The Opportunity that spent all that time on Mars went more than 25 miles. Yeah. But on the moon, the longest trip there was just under that, about 25 miles. And one of the Apollo groups of astronauts did that in about 3 days. So compare 3 days to 10 years, and you can see how much more efficient humans are at exploring with a moon buggy than a rover is.
Now, this is a question I had also, because I did not realize until Eric was talking about it that Perseverance was going to collect samples and like make little drops for humans to pick up in some future date. So how are those samples going to be collected? We have an idea of when that might happen. Will it be remote rovers that pick it up, or are we thinking that it won't be until humans actually get to Mars?
Yeah, so their plan is not final. We are going to store all these samples. We're going to know where they are. They're going to be these awesome places where you can go grab some science. And the next couple of missions are going to plan on grabbing them. It's so much harder to come back from Mars because, like we said, you need a skyscraper's worth of fuel to get to Mars from Earth. You need a skyscraper's worth of fuel to get back from Mars to Earth. And if you have to bring that with you, then you don't have to have enough fuel to launch to get a little spacecraft. You have to have so much fuel. So it starts to get really complicated. So what we want to do is send something there that can maybe generate rocket fuel on Mars. We can make it there instead of having to bring it with us. That's one of the instruments on Perseverance. Like Sarah was mentioning, Moxie is going to be making oxygen out of the carbon dioxide in the Mars atmosphere, maybe building up some oxygen. We are going to send maybe a fetch rover to touch down, grab some of those samples, bring it back to an ascent vehicle and make it all the way back to the Earth. Maybe if this experimental drone works out, it won't be a fetch rover. Maybe we're going to send a mission where a helicopter will lift off, pick up all those samples, come back to a rocket, and then blast off to the Earth. Sometime later this decade, I'm hearing 2026 for when we can expect that next window of sending things to Mars, when we might send something to actually gather them up and send it back here. So we might not actually have those Mars rocks in our hands in labs on the Earth till 2030.
Yeah. Cool though. So February has been kind of a big month for Mars. We've had a couple people ask/mention about, I think it was China and with the UAE, both either put something into orbit or landed within this month. Is that true? I don't know much about the missions.
I don't know either, to be honest.
Yeah, so the missions kind of cluster together because of how Earth and Mars move around the sun. And if you think about trying to hop from one to another, it's like moving cars on a racetrack. If you want to jump from one window to another in a race car, you don't do it while they're on opposite sides of the track. You do it while they're passing each other. And so every maybe 2.5 years, as Mars and Earth dance around the sun, there's that nice, easy place where you can make that hop, and it's the most efficient, and it only takes about 6 months. And so everyone kind of clusters their missions together. Perseverance is just arrived today, and there was 2 other missions that successfully arrived. I think Sarah probably has it now.
I have something unrelated but very exciting, which is that Perseverance has sent its first image back.
Oh,
pretty awesome.
It took no time.
It took no time, so I can share. It doesn't look like much, but hey, it's Mars. So here we go. We can see this. Look at that. There it is.
It's there.
It's like this little camera took a dusty picture of Mars. So
yeah, like a little porthole.
Exactly. Just a cool sort of little update. So it was able to take one little picture. Probably
looks like it's still making its way out and around and stretching its robotic arms. But I'm thinking that might be a good spot to wrap up our program today. As I said before, the 3 of us and many others at the museum, we could sit and talk about this forever. I know it's getting late in the day. So I want to thank Eric and Sarah so much for all of their amazing information. Their brains are way more full of all of this space stuff than even mine. But I bring the excitement, and it's super exciting that we had so many friends joining us today. And hopefully some of you will tune in next week. As I said, it's next Wednesday at 3:30. If you check the Museum of Science website, you'll be able to get the link to sign up for it, so you can get the Zoom webinar link. You can also always watch either on Facebook Live or YouTube Live. Those are both archived there, so you can even go back and rewatch this particular live stream if you so choose to on either Facebook or YouTube. Again, I want to thank everybody for coming out today. Eric, do you have some closing slides or no?
Yeah, I'll put one up that just has some information about the podcast that I mentioned and a way to support us.
Yeah, so we super appreciate everybody coming out today, and definitely check back with us and ask more questions. We love getting great space questions. Excellent. But thank you again.
Thanks, everyone.
Bye. Thank you.